we talked about in complete case analysis is complete case analysis is all about when you drop all missing values. Now, how to drop all missing values? First of all, you look at rows and you drop all the rows which have less than 5% of the missing values, and make sure that it is following missing completely. The data is missing completely at random. Even if it is not missing completely at random, if it is very less than 5%, like 1%, you would still accept it, but that is not an ideal way to do it, and that is what you always avoid. Now, the second thing is, once you got rid of all the rows which had less than 5% data, what about all the other rows? Means when I talk about complete case means I'm only looking at the complete cases. That means all the columns, all the rows which have data, and I'm taking a look at only those data points. So that means when I drop all the rows which has less than 5% data, missing data, then we go to the columns and we drop all the values or all the columns which had more than 5%. Means, for example, if any particular column had more than 5% of data, we are going to just drop that column instead of dropping all the rows. Okay, so we are going to drop those. So all columns missing greater than 5% of data. This is not an ideal scenario, but I showed it to you that this is what you can do just to take a look at it. If you have a lot of data points, this would still work fine, and it would give you a good naive model to compare your rest of the other models, but that would not be an ideal case scenario. Then we talked about that there are numerical kind of like variables. So if I talk about numerical features, then how to handle everything about numerical feature, it's kind of like a bit different. So when we talked about numerical features, we talked about that there are several different techniques. One of the technique is univariate, and one of the technique is multivariate. So when I talk about univariate and multivariate, so univariate, we talked about that there is mean imputation, there is median imputation. Today we are going to talk about this one, and we are going to look at the code, and we are going to look at in which situations you should use mean imputation, and in which situation you should use median imputation, and in which situation you should not use it. So if I give you a practical advice, in practical applications, majority of the time this is not used as much. It is used a lot in tutorials and YouTube videos. People have been using it because it is very easy to implement. But it is not the recommended thing, and because there are more efficient ways to impute data than these. Yes, these are simple, but there are more efficient ways. And in practical scenarios, you would not use them. The second thing that you can do is you can use an arbitrary value. So what is an arbitrary value? Any random value you pick up and you replace all the NaN values or all the missing values with that arbitrary value. That arbitrary value can be anything. For example, like it can be any number which is not present in the data. For example, like you just give it a random number. For example, if all the values are positive, you just give it a -1. You can give it 99999, or you can give it 10,000 or something. So you just make it so different that model can identify that, oh, this particular value is something of a different kind, and it treats it well. So because if you remove all the missing value from your data, that is bad for your data, because in production, your model is not capable of handling missing values. So this is one way to kind of like not remove the missing values, but still tell the model that, oh, this is a missing value. So it's kind of like a way to tell the model that be very careful about this particular feature and this particular value. Excuse Then was the end of distribution. So this one an arbitrary distribution. So this one and this one are very much similar. Now you must be saying that why just use an arbitrary value? I can use a value which is at the end of the distribution of the data, because this way the overall distribution of the data, main distribution, does not get affected. And another peak, for example, like if you have a peak like this, then when you pick up a data at this particular point or this particular point, and if you have, let's say, 30% missing values, this part of the data would remain as it is, and you're going to get a peak over here as well. So this way, which means if your data is part of this particular section, then your data would work just fine. And if it is part of this, it would be able to interpret it that, oh, it is something random or something arbitrary or something missing value, or something out of the ordinary, something happened here. So that means your model will be able to train itself in a way that it can identify between values from this particular distribution or this particular distribution. So that is another way. So these two are very, very similar. And basically, this is end of distribution is a better way. So when we talk about arbitrary, people ask about, oh, what number should I pick? Any number. Then we can say that, oh, just use a number at the end of the distribution, either at the start or either at the end. So I'm going to talk about it in our next video. So in today's video, I will be talking about mean and median imputation. I'm going to talk about all the pros and cons of it. And let me summarize all these techniques as well, which we're going to cover. So I'm also going to talk about random imputation. Now, random imputation and arbitrary imputation are different, because right now I'm talking about univariate imputation. When I talk about univariate, so univariate means something like this. For example, like if you have data, for example, like if I make few columns here, in fact, I don't need it. So what I can do is I can just make few columns here. And when I make these columns, what I can do is, let's say this is my feature number 1, this is my feature number 2, this is my feature number 3, and so on. So we have a few values here and there. So let's say this value is there, this value is there, this value is there, this value, this value, this value, this value, this value. Let's say this value is missing. Let's say this value is missing, or something like that. Now, if I am imputing the data by taking a look at only this column and ignoring all the other columns or the influence of all the other columns on it, then I'm doing is univariate imputation. And what about multivariate? Multivariate means if I'm changing this value, then I'm going to take a look at what was the value here and what was the value here. Since I'm using neighbors or information from the neighboring features as well, that means this is why we call it a multivariate imputation. And you can see that why multivariate would be a good choice. So let's continue talking about it. So this random one is something where what I'm doing is this missing value. What I do is basically, first of all, I look at all the values which are present. So this one is present, this one is present. So I will pick randomly one of the present values and fill this value with the random value out of those. So which means instead of picking a mean and median, because mean and median fills all the missing values with one exact same value. But when you do the random one, it picks a random value out of the possible given values and it fills the missing values with one of the random ones. So random one works better than mean and median imputation. So I'm going to show you that in so technically all of these would be covered in our next video. So I will talk about arbitrary end of distribution, which are pretty much same, and then I will talk about random one, and then I'm going to show you an automatic way to figure out which strategy is the best one, or which parameter should I use. Should I use the mean value? Should I use the median value? Should I use the arbitrary value? Or should I use a random value? Which value should I use in order to get the best results. I'm going to show you an automatic version of it. So what I'm going to do is I'm going to use a grid search CV and show you how to use it to set up an automatic search for the best parameter for your imputation if you are doing univariate imputation. And for multivariate imputation, I'm going to talk about KNN imputation and I'm going to talk about iterative. So these are the things I'm going to talk about. So if you already are familiar with what I'm going to talk about, that's good. But since this video other people are watching, and if they are watching for the first time, I'm kind of like covering it for them so that they know what exactly would be covered in the rest of the streaming, because I will be streaming every Monday, Wednesday, and Friday at the same time. Means at least until December. That is what my plan is, and then we will see how much we were able to cover and things like that, and then we will see what we can do from that point onwards. So let's get into mean and median imputation. So when I get to mean and median imputation, the first important thing, the very first thing that comes to my mind is it is very easy to implement. Why anybody would be doing it? The reason is it is very easy to implement. Okay, so if it is very easy to implement, that is its pros. So if I talk about the pros and cons and things like that, the biggest pro is it is very easy to implement. And then if I talk about cons, so the biggest con is when you use mean and median imputation, you change the distribution of the data. So change the distribution of data, or the feature we are talking about. What does that mean? Let me show you. So for example, you have a distribution like this. So this is a normal Gaussian distribution. The mean of this normal Gaussian distribution would be somewhere here. What if you are imputing the value? So let's say I'm doing mean imputation. What if you are imputing the value with the mean? Which means, let's say you have about 30% missing data. And you replaced all. So right now, this is the distribution of the data when I'm ignoring all the missing values. Which means right now, those 30% values are not part or not contributing to this distribution. When I replace these 30% values with the mean value, what's going to happen? This particular peak is going to climb up, which means the distribution is going to go something like this. It's going to be squeezed up and it's going to pump up because now 30% of the values, I added them right in the middle of this distribution, which means this particular distribution got changed. And when the distribution got changed, it changed the whole probability density of picking up any value or things like that, which means it's going to affect your results as well. So when you make a model, that model is going to be affected because of this change in distribution. So when the distribution of a particular data set changes, it changes the capabilities of the model that was trained on that particular data. So which means this mean imputation is going to do that. Now, for example, if I talk about mean, so if it is 30%, I would not recommend it. Not recommend it. But when to use mean? If the data missing is less than 5%, then you can still use mean imputation. But let me tell you, let me give you an advice. Always avoid this if you can, because using the multivariate techniques would be the best thing to do depending on your data size and what kind of situations you have or what kind of data you have at your hand. Okay, so if the data is less than 5% missing, then you use it and it's not going to affect the mean of the data as much. Okay, but it's going to change. What else it can do? So this mean I talked about, it changes the distribution of the data. The other thing it talks about is it changes the relationship with other variables. It changes the relationship with other neighboring features. So if it is affecting the relationship with other features in terms of statistics, we call it covariance. That means its covariance is changing as well. And along with that, correlation with the other variable is also changing. Which means now we get a very good idea that why this mean imputation or median imputation does not work really well. So far I did talk about only about mean imputation, that here I'm using, and this would be the effect. And if you use the median, it's going to do the same thing at the median. So here the median at the mean value, it kind of like got bumped up. If you replace it with the median, then median value would got bumped up. And now you would be saying when to use mean and median. Then the choice is, this is a normal distribution and this one is not skewed, or you can say it is symmetric. The tail on the left and right hand side is symmetric, or you can say the mean and median are overlapping. So when mean and median are in the middle, right at the middle, you can say that it is not skewed. So when it would be skewed, the skewed data looks something like this. So it can be skewed to the right and it can be skewed to the left. So when we use the word skewed to the left and skewed to the right, what it means is, so this is one of the situation, and let me show you. This would be one of the situation, and then this would be the other situation. So this one you can see over here, this is the median of it, and over here this is the median of it. But the mean value has been shifted either on the left and or either on the right side. So when it is on the right side, you call it is skewed to the right. When it is on the left side, you say that it is skewed to the left. And based on that, you determine it. Since mean is not in the middle at the peak, that is the reason why when your distribution is skewed, then whether to use mean imputation or median imputation would give you better results than mean imputation. So between mean and median, you always have to take a look at this data size. That means the data size, if 5% and less is missing, then it can be used, but it is not ideal. But if you want, you can use it. But when to use mean and median, it is all about the distribution. That means if the distribution is skewed or not. If that is one point, then we talk about covariance and correlation as well. Then it has another drawback as well. So I have already talked about few drawbacks. Okay, so I don't know where it is going. How? So I've already talked about few drawbacks. Let me talk about another drawback. So what happens in the drawback is sometimes it creates new outliers. So this particular mean and median imputation can create new outliers. So when I talk about outliers, let me give you an example. If you are familiar with box and whisker plot, I can give you an example using that. If you don't know box and whisker plot, let me show you what exactly it is. So for example, let's say I have, for example, like age of several students. So let's say I have an age of a student, let's say 20 years, then there's a 22 years, then there is 18 years, then there's 25, then there's 24, then there's 22, So these are few ages. 1, 2, 3, 4, 5, 6. Let's make it 10 different ages. So I have 1, 2, 3, 4, 5, 6. Let's add maybe 28, then add 30, and then we have 35. So 3, 4, 5, 6, 7, 8, 9, and then we have a 12 years as well. So when we draw or when we make a box and whisker plot, technically what happens? You have a feature and you want to make a box and whisker plot of it. The first thing that happens is you have to sort it in ascending order. So you have to sort all the values in ascending order from small to bigger. That is the first thing we are going to do. So if I sort all of these values, I can see 12 is the smallest one. After that, 12, 18 is the next one. After 18, I have 20 is the next one. After 20, so I have used this one, I have used this one, I have used this one. And after that, I have 22. And then I have again another 22. And then I have, after 22, we have 24. And then we have 25. And then we have 28. And then we have 30 and 35. So first thing, when you make a whisker plot of a particular table, what happens is, or of a particular feature, what you do is first of all arrange them in order, and then you find the median or exactly the middle of it. So what would be the middle? The exact middle value. So these are 10 values, which means the middle would be 4 places down here and 4 places up here. These two values would be somewhere in the middle. I'm going to find average of it. So 22 plus 24, when you add them, divide by 2, that would be the median value. So 22 plus 24 divided by 2 is 23. So this is my median value. So if I make a box and whisker plot of it, what I'm going to do is I'm going to make a median line in the middle of it. Then what I'm going to do is I'm going to find the middle of this particular section as well. So I'm going to find the middle of this particular section. For this particular section, the middle would be one place here, and these two places. So median would be somewhere in the middle. And that would be what value? 18 plus 20 divided by 2. So this would be 19. So that means I will go and I will make a line. So for example, if this is my scale and this value is 23 and this value is 19, then I would make a line here. Then I would go down here and I would do the exact same thing. So I will find the middle. So one place here, this would be the middle. So 28 plus 30 divided by 2 is going to give me the median over here. So my 29, which means if this value is 29, then I got a box. And now you can see that in this particular box, the difference between this and this, 19 and 23 is about 4 units, and between 29 and 23 is 6 units. So this section would be a bit bigger than this section. So let me make it bigger. This section is a bit bigger than the other section. This would be 29. And now what I'm going to do is all of the rest of the values which were beyond it. So this 12, that 12 is going to be somewhere here. So this was the extreme value. Now, what are these whiskers? So these whiskers, we extend them 1.5. So technically, first of all, let me tell you. So this is my quartile number 1. This is my quartile number 2. This is my quartile number 3. And then there would be a quartile at the bottom as well. There would be a whisker here. So this would be my quartile number 4. And from this point to this point is my interquartile range. So this is called IQR, or interquartile range. And these whiskers are usually extended to 1.5 times the interquartile range. So whatever your interquartile, over here our interquartile range is 29 minus 19, 10. So 10 times 1.5 is 10 times 1.5 is 15, which means I will go 15 units from the median on this side, and that would be the end of my whisker, and similarly 15 units here, and that would be the end of the whisker. And any values like this 12 and 35, if they are beyond it, they will be considered outliers. That is how the box and whisker plots work. Now, when I say that mean and median imputation can create new outliers. For example, if my original data was this data, okay, so this was my original data, and then I had few missing values here, and those missing values now are replaced by the median 23. So if I put this 23 over here, maybe let's say I introduced 5 new values. Then what's going to happen is now you have to sort it again, and your sorting is going to be a different one. Let's do it quickly. Okay, so I'm going to sort it because 12 is already there, 18 is already there, then 20, then 22, then 22, and then I have 1, 2, 3, 4, 5 23s, 23, 23, 23, 23, 23, and after that 23, then I have 24, 25, then 28, then 30, and then finally I have 35. Now let's make a box and whisker plot again. Okay, let's make a box and whisker plot again. So which means originally I had, for example, like this was my 23. So 23 plus 15 is 38. That means this particular bar was going until 38. And I have no value above 38, which means I did not have any outlier in this particular section. Similarly, on this side, 23 plus 15, 23 minus 15 is what? 13, and then 8, I think. So this would be 8. So do I have any value 8? No. Which means I did not have any outlier on this side originally. But when I did imputation, 5 missing values, I replaced them with the median or mean or whatever. Right now we are doing the median. Let's see how it affects our box and whisker plot, and would it introduce any outlier or not. Let's take a look. Because I am taking random numbers, maybe my example would not work here, but I'm going to show you in coding, and I'm going to show you that it does create outliers. So over here, let's quickly find the median and interquartile range and everything. So since these are 15 numbers, so that means 7 from this side, 1, 2, 3, 4, 5, 6, 7 from this side, and 7, 1, 2, 3, 4, 5, 6, 7. This would be my middle. My median is still the same number. Then let's go to this particular section. So in this section, I'm going to go 3 units here and 3 units here. This would be my second value, 22. So this is 23. You can see my top value originally was 19. Now it became 22. Which means if I figure out my interquartile range, let's do it. Similarly, on the bottom side, I'm going to go 1, 2, 3, and I'm going to go 1, 2, 3, and 25 would be my value. Here, I was getting 29. You can see my box has been squeezed up. Can you see what is happening over here? My box is being squeezed up here. So my box over here is squeezed up. And if it is squeezed up, then you can guess my interquartile range would be pretty small, right? Comparing to this one. So over here, my interquartile range was 15. Let's calculate here. So it is interquartile range is 22 and 20. 25 minus 22 is what? Just 3 units big. And what is 1.5 times 3? It would be simply 4.5, which means 23 plus 4.5 would be 27.5, which means any value above 27.5 now would be considered outlier. How many values do I have above? I have 3 values, so I got 3 outliers. Originally they were not outliers, now they become outliers. So that is an interesting thing that happens when you do mean and median imputation. Let's move on to our lesson and let's continue. So I talked about different cons and different when to use. So this is the pro. Pro is simply it is very easy to implement, but there are so many cons. You have to be very careful about it. Okay, so which means it can change the covariance with other variables. It can change the correlation with the other variables. So technically, covariance and correlation are they are not similar. They're different, but they so correlation is derived from covariance. So let's quickly take a look. Variance and correlation. Covariance shows you how the two variables differ, whereas correlation shows you how the two variables are related. So correlation can only give you answer whether it is -1, 0, or 1, or in between those values. But covariance can be different. So it just shows you how the two variables differ from each other. But this one shows you that how they are related, whether they are directly related, indirectly related, or not related at all. So when the correlation is 1, that means they are directly related. One goes up, the other goes up. One goes down, the other goes down. And if they are indirectly related, the correlation would be -1. One goes up, the other one goes down. And one goes down, the other one goes up. And if the correlation is 0, that means if one goes up or down, it doesn't affect the other one whatsoever. So that is correlation. But covariance is simply telling you how different they are from each other. So shows you how two variables differ. So if their difference got changed, that means their covariance got changed. And due to the imputation of mean and median, the covariance does change. And because of that, correlation also changed. So what is the relationship between this? So there is a mathematical formula right now. Maybe let's do check out this. Yes, you can see that they are dividing uh, covariance by standard deviation to get correlation somehow. Yeah, so I think that's what I thought. It is very important to know this, not just for you. It is very important. So when you are doing these in practical situations, why people say that you need to know statistics, you need to know calculus in order to do really well as a data scientist, because if you know these things well, these things does change, it does affect a lot. And a lot of people, they just follow YouTube tutorial end-to-end projects finished in 2 hours. I don't Nobody can finish an end-to-end project in 2 hours. Either they are just giving you the final thing, you have to do a lot of work on it to understand it well, or you just want to kind of like for portfolio basis just put a project on your resume. That does not do well, because if you just copy paste a 2 hour you watch a 2 hour video, long video, or 6 hour long video, and you implemented that particular code uh, during the interview, you are not going to be able to answer every single question. There will be so many questions that the interviewer is going to ask, that why did you use this imputation? This imputation has so many different cons. Why you did not use any other one? What was the alternative? What was the reason behind it? And things like that. And you are going to get stuck over there. So we need to know this particular questions really well, so that even if you're copy pasting, you can answer on the spot, depending on, oh, this imputation I was just doing it to complete the project, and now right now currently I'm working on evaluating more variables, and evaluating more different imputation techniques, and see which technique works best. So I started, or you can say that this is my naive model. This is not my final model or updated model. Okay. So if we are good, then we can move on to the coding part. Since the data that we were using last time did not have a lot of numerical variables, since we are doing specifically numerical variables, what I did is basically I went to widths data thought. So this is widths Datathon 2022. I got the data set from there. So technically, what I did is basically I created a new. So I entered this competition, entered the late submission, and then I created a new notebook, and I got the new notebook, and now I'm using this data set. So this is the WITS Datathon dataset. You can see that I'm using this train.csv right now. So I will make this notebook available. Right now, it is not public. It is not being shared, but I will share it after the video. Okay. So what I'm doing is, let's take a look at this data set. So this data set has a lot of columns. So it has building ID, it has year factor, state factor, building class, facility type, floor area, year build. So it has a lot of variables. And I don't want to go in detail in all of the variables. I just want to show you how to implement it on numerical features, and so that you can implement it yourself. So what I did is basically I only separated few columns for myself. Which few columns? The two numerical columns, the max wind speed and energy star rating. I said that these are my X variables. And then this is my target variable, site EUI. And this is what we are trying to predict using these numerical features. So you can see this is the overall look of the data set. It has a lot of variables. I'm picking up this energy star rating, and I'm picking up this site EUI is my technically the target, and then max speed win is what I'm picking up as one of the numerical variable. So why did I pick those? Because I figured out the information, and in the information I saw that this one does not have any missing variable because our overall data size is that big. So if you want, you can quickly check out the shape of it. View is not defined. I think I have to run everything again. When we do the shape, you can see this is the size of the or number of rows. And over here, you can see this one has some missing data. This one has some missing data. So this is year build. It is not technically a numerical column, so that's why I just avoided it. This is energy star rating. This one has a lot of missing values here. And then you can see all of them have all the values, and then you can see these columns does not have a lot of values, a lot of missing values. So I picked up just randomly this one, and then I'm trying to figure out this particular variable as my target variable. So keep one thing in mind when you do any sort of data transformation. So last time I think I forgot to tell you, the first thing that you do is you just split your data into your training and validation and test set, and keep your validation and test set separate, and do all the analysis on your trained data, because you have to think in a way that, let's say you have a data set and you are training a model which is going to run on a data that you have never ever seen before, which means not even you can use your data in the analysis part. Means when you are kind of like just taking a look what is the distribution of the data, or univariate analysis or bivariate, you cannot even use that set. So you have to split the data before that point. So once you get the data, split it and only take a look at the training part, and then explore the training part and do everything based on the training part. Okay, so that is what I'm doing. First of all, I figured out df.isNull.mean, and you can see it is skipping a lot of values. If I go and if I can set PD options, and I can display all the columns, which I did, I believe, last time as well. So I'm gonna just copy paste this part from my last file, and you can see that I don't unnecessarily I don't write the code. If I already have made a template for myself, I'm going to use that template. I don't why, what is the point? Means it's kind of like, what is the point of inventing the wheel again, all over again? Yes, for practice purposes you should do it, but this is something you have done so many times that you just copy paste. You know that where to look, you just go and grab it and put it there. This is going to save you a lot of time, and that is what I'm doing. I'm pulling out some code from my previous notebooks and putting it all together and creating a new notebook. Because that work I have already done. I know how to work, how that works and everything. You should be also doing that, creating your own templates. Excuse me. Okay. So now we have already taken a look. I'm not going to going in detail about these points because we have covered that in the last section. And now if I run this, you can see now it is displaying all the columns here. You can see this one has 54% missing, 55%, 54%, 60% missing. So what I did is basically now I don't want all the other columns. I just want these because I'm doing imputation here. So I just picked two columns which had some missing values and they were numerical. And I picked up my Y as well because I'm going to show you model output as well at the end. So I split my data into 80-20 split, and this is my random state. My number, you have seen that my LinkedIn ID is Salman Khalid 22. My GitHub ID is 22. My Gmail ID is 22. So everywhere, this 22 is kind of like a number I always stick with. So you can pick up any number you want. And then you can look at the shape of the, I did not split it. I did not even define it. So you can see the data, this one, X variable has 60,000 variable columns now. Now I want to take a look at the null values. So this one has 54%, this one has 35%, a lot of missing values, which means complete case analysis is done. I cannot use that. It is not ideal here. If I'm using complete case analysis, I need to drop these columns. And these columns are pretty important because I have done this particular project, used this data and made a project on it. I know that these are very important columns. Then what I'm doing is I'm calculating the mean and median of these particular variables. And now what I'm going to do is I'm going to create new variables. So for example, like I'm going to create new variables or new columns inside my X train. So X train, then I'm going to do wind underscore mean, and then I'm going to write X underscore train. So I'm going to copy this. So I got this and I'm going to fill in it, and I'm going to fill it with median underscore age. So over here, I have already calculated the median. Why I'm writing the age? Because I think I'm using my old template. That's why I'm writing. So this is median wind. So what I did is basically, so here I'm writing median. Or let's stick with the same thing, otherwise I'm going to mess it up. So this is mean wind. Okay, so this is mean wind, and now I'm going to copy and paste it, and I'm going to so this would be median wind, so I'm going to call it median wind, and I'm going to call it median wind. And then similarly, I'm going to copy this whole thing, and I'm going to write it here, and then I'm going to call it mean rating. I'm going to call it mean rating, and I'm going to copy energy star rating. Energy star rating. This would be mean rating. This would be mean rating. And now I can copy and paste this over here. And you can see that what I did is basically I created 4 new columns in my X underscore train. And so everything is good. So now what I can do, so I can look at a sample. So maybe let's take a sample X underscore train dot sample. Let's take 5 sample random variables. You can see that this is my maximum wind speed and this is my maximum. So this was nan value and it got replaced by the mean. This is over here, it got replaced by the median. You can see the difference between the values is pretty big. This one has mean rating of this one. So this one has nan value here. It got replaced by the mean value, which was 61. And median value was also 61. So mean and median were same. So you can see the energy star rating, the mean value and the median value are technically same, which means most probably this is a perfect uniform, not uniform, Gaussian distribution, normal distribution, most probably. And this one, the wind one, is not a Gaussian one. It is symmetric one, or skewed one, not a symmetric one. So which means it is skewed more towards this one as compared to this four, because mean is kind of like shifted to the right. So this gives you a very good idea. Now what we can do is we can look at the variance, and we can let's look at the variance. Okay, so what I'm gonna do is I'm gonna do x underscore train, and I'm gonna just copy this. I'm gonna write it because these are pretty big names, and I'm gonna calculate the variance of it. Okay, so and then I'm gonna maybe just let's write the print statement as well. Variance of max win is, so this is my variance, and now I'm going to copy paste it. So this is what I'm writing here. So variance of wind is this. Variance of wind underscore mean is wind underscore mean, and then copy this. Variance of wind underscore median underscore wind is this. So you can see that the variance of the original wind column was 41, but variance of wind mean. So this particular, when you did the mean imputation, this column, now the variance got changed a lot. And then the median also got changed. And there is a difference between mean and median as well, which means something bad happened here. Okay, so this is not a good thing, and you should be looking at these things. And similarly, I can take a look at mean rating as well. So let me just copy and paste this thing, and maybe I can create it here, and I can say variance of wind, no, energy star rating. Let's copy this, paste it, paste it. Then mean rating. So this is mean rating. This is mean rating. Then I'm gonna go and grab median rating. Median rating. Median. You can see that originally variance of energy star was 821, and the variance got changed, even though mean rating and median rating are giving me the same answer, which means for some reason mean and median did not do much difference, so they are pretty much the same number most probably. Okay, so this is something you need to take a look, and you should be able to do it. Now what I can do is I can plot the distribution, and I can overlap the distribution, and I can see originally what was the distribution, whether it got changed or not. Let's plot the KDE plot. So what I'm going to do, I'm going to start with figure. So equals plt dot figure. Let's create a figure first. Then I will create axes. So fig dot add underscore sum plot, and then I'm gonna write 111, and after that I'm gonna do x underscore train, and I'm gonna do the original one. So for example, this one. So I'm gonna do this one, and I'm gonna do plot, and I will make it kind is equals to KDE kernel density estimation, and then finally C's is equals to C's. And then I will do the same thing. So I did for energy star. Maybe let's do this one first. So I'm gonna do this one. And then I'm gonna do this one. So what I can do is I can just do copy and paste, and then go and change this. So this is KD, this is axis, and then I can give it a different color because I don't want them to be same color, and then I won't be able to recognize it. Maybe let's make it red. And then I'm gonna copy this whole thing, and I'm gonna paste it here, and I'm gonna do median weight. Median weight, and let's give it a green color maybe. So and I can add legends and things like that. Maybe or, okay, let's wait. So I'm gonna write lines, comma, labels is equals to access dot get underscore legend underscore handles underscore labels, and then finally access dot legend lines label comma location is equals to best. Then I can do show. So if I do this, I should be able to get the graphs. Here you go. You can see that maximum wind speed, the blue one, is the original one, and it had a bump here, it had a bump here, so it had trimodal, you can say. Then mean one is the orange one, which has one bump here and the other bump here, so it got created two bumps. And then the median one is the green one, which got kind of like get generated. So you can see median one is still sticking to the same pattern. It has a peak here, and then it has a small peak here and a small peak here. But mean one is not a good one. So you have to always be careful in these particular scenarios. Okay. Yes, always. Ideally, we would want it. So we would want the variance to be not disturbed. The more the variance is gonna disturb, the covariance is automatically is gonna change with the other variables. So this is something we need to keep in mind. And you can say that this is not a good idea on this variable to apply mean imputation or median imputation on this side. So here I can totally see this is wrong. This is not a good thing. So what I can do it for the other variable as well. Let's do it. Let's copy and paste this whole thing for the other variable and change the names. So let's do it for the other one. So this was mean rating, energy star one. So let's do energy star here. So energy star was mean rating, and then it was median rating. And here you can see that something odd is happening. Where did the red one go? I think the red one is overlapped. You can see the red one is automatically just below the green one. So red and mean rating and median rating. Remember, mean and median were giving me the same thing. So mean and median kind of like are overlapped. They are so very well overlapped that you cannot even see the red one. Okay, so but you can see that the blue one and the green one are totally different ones. And in this scenario, maybe this will work out really well. Why? Because maybe I can assume this to be an arbitrary value with which I changed. And when you have a value which is kind of like an extraordinary, which is looks like an outlier value, then your model is going to be trained on it, and it's going to be able to handle the missing values really well, because your mean and median are working like an arbitrary random value. So this is what you're gonna get over here. Okay. Now what we can do is we can also check the covariance, x underscore train dot covariance. Let's try it. So you can see the covariance over here. Max wind speed with energy star rating is this much. And this is the original one for max wind speed, and this is the original one for energy star rating. For but now you can see wind mean. So this one has a with the energy star rating, you can see it got changed. This is max wind speed, this is wind when you replaced it with the mean, all the missing values. You can see here the correlation was positive, a bit positive, and here it is a bit negative. Which means previously, not a correlation, sorry, my bad, it is covariance, which means covariance did change. So here this number cannot be between -1 and 1, it can be beyond that. So here you can see that this is 21. Originally it was 41, but median, so it is with median, so my bad. You have to take a look at median with the energy star. You can see it changed. Originally it was 0.042. And then similarly, mean rating with the uh, max wind speed, it is this, but originally it was this. And similarly, median and mean were kind of like pretty much same. That's why it's same. But you can see what is happening over here. And what I can do is I can also find the correlation, x underscore core. So my bad, x underscore train dot. So when you find the correlation, this correlation would be between -1 and 0. You can see this max wind speed and energy star originally had this correlation, but now when you replace it with the mean, now it is negative, a bit negative. Even with the median, it is a bit negative. Originally, it was a bit positive. And similarly, mean rating, it has originally, so this mean rating had originally with max wind slightly positive, and here it became slightly negative, slightly negative. So it is not a big difference, means I would still be able to, means if I want, I can do mean imputation on the energy star rating, and it can work really well. But maybe right now I would note it down, and at the end when I have already done multivariate analysis as well, then I can see which one is doing better job. So we can always do grid search CV at the end to check for the best parameter or best technique that is going to work for us. Okay, so this is all of it. Now I can also show, so I have shown you all the things over here. So first of all, I showed you that it's going to change the probability. Then I also showed you, so I have already shown you this part, so that it changes the probability. I also showed you that it changes the covariance. I also showed you it changes the correlation, but I did not show you this part. Let me show you this part. Okay, so let's make box plots. So for box plots, it's pretty simple. I'm gonna do x underscore train, and then I'm gonna just take the maybe max wind speed, and then I'm gonna take wind mean, and then I'm gonna take median wind. So I'm taking all the three columns for wind, and let's see what kind of results we got. So let's plot box plot for all of them. Box plot and see. So here you can see that this is my original one. Here something odd happened, and here something else happened. So you can see that this one and this one looks pretty similar, but this one got changed a lot, and right now it is not visible. But what I can do is I can also do a violin plot using Seaborn, and that can give me a better idea. But right now I'm not gonna go in that, so I'm not covering the plotting techniques and everything. But you get the idea that you can always check. And if you are not sure, you can always calculate the interquartile range, and you can from that interquartile range. So the way I have already done mathematically or numerically here, you can all do it over here as well. So you check for all the things before you decide whether which imputation technique you're going to apply. So what we did so far, we covered that we have seen that by doing the mean and median imputation, it changes the distribution for some variables. If it does, we don't want to use this. Sometimes it does change the relationship with the other variables. Covariance and correlation did change. And sometimes it also introduces the outliers. So as I have already shown you a mathematical example here, you can understand it pretty well. But if you want, you can do all those things over here. Right now, I'm not doing it because the um, uh, um, video is already being more than 1 hour, and I will kind of like stay here. And one more thing, I did not use Scikit-learn here. So I did everything on, you can say simply, I use fill NA to fill the mean value. I could have used Scikit-learn as well. And I'm going to show you quickly how to use Scikit-learn to do that as well. So for using Scikit-learn, maybe I'll just write using Scikit-learn. So what I'm going to do is, first of all, I have already split the data set. So I'm going to use imputer 1 is equals to simple. So I have already imported all of this over here at the top. So I have already imported simple imputer here, and I have already imported column transformer. If you don't know what is a column transformer, I'm going to break it down in a separate video, but right now I'm not just going to use it, and you will see that what it does. Technically, what it allows is, it allows you to apply different strategies or different things on separate columns. If you want to apply mean imputation on one column and median on the other one, you can use column transformer and tell, oh, apply this on column 1 and this on column 2, or this on column 3, and so on. So you can use multiple techniques on multiple columns at once. So but over here I'm going to use simple imputer. I think I did not write this well. So imputer, and then strategy would be, I'm going to use one is median. So one of the imputer is this one, and then I'm going to introduce another imputer. I would call it imputer 2, and I'm going to copy this whole thing, and I'm going to paste it, and I'm going to change it to mean. So first thing, I just instantiated it, and then I'm going to use transformer is equals to column transformer, and then I'm gonna put a list of the imputers I want. So then I'm gonna put the tuples here. So I'm gonna say imputer 1 should go. It is not a tuple. So I'm labeling them. So I would call it imputer 1, and what imputer 1 is? It is imputer 1 itself. And then I'm gonna apply it on which column? I'm gonna apply it on so max wind speed. So should we apply median here or mean here? So I'm just gonna apply anyone. So I think that's fine. So that is what we have, and then I can put comma, and I can introduce another one. So I'm gonna have computer 2 comma, what would be the name of the other column? Energy star rating. So I did that, and then I'm gonna do this part. I'm gonna say, so this is gonna happen to the missing values, and what's gonna happen to the remainder of the column. So technically, right now I just have two columns. I'm applying these two different imputations on two different columns. What if I had more columns and I don't want to apply any imputation or any technique on the other columns? So I need to tell what's going to happen to the remainder of them. Since I don't have any, I don't need to mention that thing. But just for the sake of understanding, I can put remainder is equals to pass through. And if you don't know what that means, you can always search this column transformer on Google, column transformer, Scikit-learn, and you can go and read the documentation. So this documentation is going to tell you what this is. So this is a remainder, drop, and pass through. Whether you want to drop all the remaining columns or you want to pass through, that means don't touch them as it is. By default, it is dropped. So if you don't write anything, it's going to drop. So I'm going to write it. Okay. So if I do this, it's going to instantiate it. And now I'm going to fit it. So let's fit it here. So transformer dot fit, and which column I should fit on? X underscore train. I'm gonna fit it on X underscore train. So it got fit. So when I say fit, that means it got trained on it. Now I'm gonna do is named underscore transformers underscore, and then I'm gonna do let's take a look at imputer 1, and I want to take a look at the statistics of the imputer 1. You can say that imputer 1 was max point, and my statistics is this. Did we get the yes? So it was this. Okay. We were doing median, so yes, it was this. So we got it right. So this was the statistics we just figured out, and then I can do it for I can apply it or do it for the other imputer as well. So this would be imputer number 2. You can see this is 61.098, and I'm getting the same thing, 61.098. Where was it? So this was these things, but so 61.098, this value. So we are getting this value. You can see this is the median value we were getting, and this is the 61. So we just did that. Scikit-learn can also do that. Okay. So now if you want to apply it on the whole data set, you can apply it. So this is just the statistics, but if you want to apply it, so far I have just trained it. It has not transformed my data yet. So I need to transform it. So if I want to transform it, I'm going to say X underscore train dot, maybe I'm going to call it equals transformer dot transform. I'm gonna pass X underscore train. So keep one thing in mind. Look at this. I trained this whole thing only on my train, and now I'm gonna apply it on my train and test both of them. So you cannot use your test data set on anything. Yes, you're gonna do the imputation based on the training that has been done on the training set. Okay, so you have to do that. So here I'm going to say my X underscore test would be this. is test, and I'm going to say, and this would be trained on. So this is already trained. I'm just transforming it. So when I transform it, then what did I do? Oh, few columns are missing. Uh, yes, I did not add those columns in my test data set, so I think they are missing. So what I can do is I can just comment it out for now. This one X has already been trained. Specifying the columns using strings is only supported for pandas data frame. Oh, I think so. Pandas have recently, so one important thing, pandas have recently updated their some of the things. One of the thing was previously when you used to do this transformation, it used to create a NumPy array. Now it creates pandas data frame. So I think the code has been changed or modified a bit, which I have not updated in my notebook. Okay, so what I'm gonna do is I'm gonna put this notebook on Kaggle. I'm gonna leave it. I'm gonna share the link with you. You can go and access it, download it, use it, and I'm gonna update that in the notebook. Right now, I think we are. It's already a lot of time, so I think I'm gonna finish the streaming right now. And if you have any question, feel free to bring in the questions and feel free to ask me on LinkedIn, on YouTube. And I would really recommend you, please ask me questions. Comment down after the video is being uploaded. Give me feedback and share it with your friends. And don't forget to like it. And if you haven't subscribed to the channel yet, please subscribe to the channel. And thank you so much for staying with me. And if you have any questions, feel free to reach out to me anyways. LinkedIn, YouTube, whatever way you